In this open data exploration exercise, you have data on the number of plastic particles found in 10 amphipods at the bottom of 6 trenches in the ocean. There is a video. I'll get that. That's linked here in this data spreadsheet. This data spreadsheet is provided in the exercise, but this data is data collected based on the number of plastic particles found in these 10 amphipods. Amphipods, they would look to you like some sort of shrimp without claws, almost like an insect on the bottom of the ocean. And these are at the bottom of the deepest trenches on the planet. The Isobonin Trench, the Japan Trench. Each of these is a trench in these columns. And they pulled up 10 amphipods. They used a trap to collect them, and they then used microscopes to determine how much plastic, there were plastic particles inside the amphipods. You see, people thought the bottom of the trenches were clear of plastic, clean. I mean, that was the idea. We're talking 5-6 miles underwater. Those are, in theory, those should have been pristine, clean environments. Nobody lives down there. Nobody goes down there. And nobody's actually throwing anything into these trenches for the most part. I mean, nobody's going out there and dumping their garbage into these trenches. This is open ocean. So it was surprised that there was plastic particles found in these trenches, in these amphipods. But so they've done this research, and indeed many of these amphipods have plastic particles. Some don't. The zeros would mean they had none in them. They happened to take 10 from each trench. That's what they did. So you have really got 6 samples here, and you've got, consider that your population, if you will. That's all we've got. Nobody else has gone back down to collect amphipods, so that's all we've got to work with, are these 10 amphipods. So what can you tell me about this data? You can't just throw that up on a screen and say, here's what we found out. Interpret it for the audience. You're the statistician. They've come to you and said, look, we got numbers. Now what? Well, what useful statistics could you report in this data? Are there any that, if you do those statistics, are there any that stand out and look different or unusual? And if they are different or unusual, here's almost the harder part. Is it statistically significantly different? That number, you see some number and goes, oh, that number's not the same as the other numbers. Now, what number am I talking about? I don't know. You're the statistician. Explore this data. In Chapter 1, you looked at sample size. In Chapter 2, measures of middle, measures of spread. In Chapter 3, you learned about histograms. I'd be remiss if I didn't mention box plots. You've also learned how to do 95% confidence intervals. So some of these tools that you've learned early in the course, see where they can get you. Can you find anything unusual or different about this data? 6 trenches. The Japan Trench, the Kermadec Trench, and then report that. Now, in this particular presentation, you'll submit the spreadsheet, but in future presentations, you'll be submitting a slides, a more traditional slides presentation, the way we usually do presentations. But for now, just focus on getting the statistics sorted out, and then we'll tackle the more complicated business of you putting this data into slides, or putting the results more accurately into slides and presenting that. So take a look at it. What can you say? Are these trenches all basically the same, or are there differences between trenches? What can you tell me based on the data you've got about these different trenches?